Purpose of this video is to show how to use the LiDAR building extraction tool. This tool was developed at the Earth Data Analysis Center at the University of New Mexico in Albuquerque, New Mexico, thanks to funding from FEMA Region 6. In recent years, LiDAR mapping, or laser mapping as it's otherwise known as, has become much more available. In this graphic from the USGS circa about January 2018, you can see everything in green where there's areas that have been covered by large-scale LiDAR mapping projects. This data provides 1 meter spatial resolution digital elevation models, as you can see to the left. This compares favorably to what we see on the right, which is the old digital elevation model. The elevation data here provides a lot better capabilities, including better slope maps, maybe better aspect maps, contours, a whole realm of different kinds of data products that have now become available to the user here. But not only is there just the LiDAR data, as in the form of a digital elevation model, but you also have the point cloud data. And the point cloud data maps not only the surface information, but also the above surface information. This comes from the actual process of the LiDAR pulse hitting the ground or hitting anything else that it comes in contact with. So when it comes back and is recorded on the LiDAR device, it records not only the X, Y, Z value, but also the intensity, how strong the value was, the return number. When it hits a soft object, there's multiple returns that can happen. If it hits a hard object, it's usually just one return. But each pulse that splashes back to the sensor is recorded with a certain return number, as well as it provides information here with the most recent LiDAR type data, what we call LAS data or .LAS type of data sets, where you have each point can be also classified. Classifications can run a gamut of different kinds of things. Usually the data sets that get delivered in most product deliveries only provide a unclassified, a ground, a water, and bridge deck classification. That then provides a whole lot of other information, surface information that is available in the point cloud that is kind of put into the unclassified area. Theoretically, getting at the building information within that LiDAR cloud shouldn't be too difficult because, as mentioned before, surfaces that are soft, like vegetation, have multiple responses, multiple returns. But buildings are hard targets and should have just a single return. So you should just be able to sort out all the unclassified data that has just a single return, and you should have your building information. But in this example, we see in this area here, where we took the information from the LiDAR point cloud and just sorted out all unclassified data that had a single return, and you see the buildings there, but you also see a lot of other clutter, which is essentially the vegetation. Here's an oblique image of that same area, and again you can see a lot of vegetation as well as a lot of buildings. This is probably due to the fact that within the plants there are also a lot of hard objects there, such as branches and trunks and stems, which if they don't intersect with any other tree or any other part of the tree, then turns into just one response back. So here comes the issue here, where we had to develop a tool to help sort out all the vegetation noise and other things from the actual building tool.